Greetings my excellent friends, and welcome back to this Python 101 programming series. And in this video we're going to be looking at two concepts today, the first being scope and the other one being mutability. So I'm going to minimize Rufus, goodbye Rufus, and go over to PyCharm. I've created a folder called scope and a file just main.py in PyCharm. So first things we're going to do is we are going to write a variable. We're going to say robot is equal to vector. So we're going to write a string. We're then going to write a function called change, def change, and we're going to say robot is equal to pepper, because pepper's nice, I like pepper. We're then going to say print robot, and then what else? We need to call change. And finally, I'm going to print out another robot there. Oh, and I will also put one here as well. And I'll make it all PEP8 compliant. And put one there. PEP8, by the way, if I haven't already mentioned, is kind of the formatting chosen, or like a Python standard for how to format your code. Okay. So what I want you to do is kind of pause the video and maybe have a think, or write down on a piece of paper what you think the output of this is going to be. Because some of you might know already what's going to happen, some of you might not, and it'll be interesting to see what you think it might be. So I'm going to run it now, and as you can see we've got three different values as we were expecting. However, one of the I would argue that you might have thought we would have vector, pepper, pepper, where in actual fact we've got vector, pepper, vector. So what's going on here? Because it looks like we've created a string called vector, we're printing it out, and as we can see that's worked perfectly fine. We've then gone down to this change function where we're going up. We've then got our robot variable, we are changing it to pepper, and printing that out, and as you can see we do indeed print it out. And then finally we go down to this final print statement, and it prints out robot, where you might have thought it would be pepper, but instead it's vector. So let's have a think, what's actually going on here? Well, I think sometimes it might be quite useful to see, if we're actually dealing with the same variable or not. And what I mean by that is, when you create a variable in any sort of computer program, it assigns a block of memory, okay? And it assigns a block of memory in the RAM, and it assigns with it a unique ID. And it's quite useful to have a look at the ID, because then we can see what variables we're dealing with. So what I'm going to do is I'm going to write out a print statement called ID. And I'm going to write out robot. So this will give me the ID of the robot variable that we're dealing with. I'm also going to copy and paste it and put one inside the function variable. The function, not the function variable, the function, yes. And finally I'm going to do another one here. So what are we going to see here? Well, we've got a vector, the first variable, which ends in 528. We've then got another one, which is quite interesting, and it ends in 616, and then we go back to 528. So it seems that this print statement is calling this robot variable, as is this print statement is printing this robot variable. But as you can see, when we define it as pepper, it's creating a new ID. And when I say it's creating a new ID, I mean it's actually creating a new string object. It's not reusing a string object. It's not saying, oh, that's where the string object is, I'm going to change this. It's not doing anything like that at all. It's actually creating a new string object. And if we go over the little thing, I'm going to just put that in, make it PEP8 again. If you go over the little squiggly line, you'll see that we've got a error, well, not an error, a warning, saying that shadows name robot from outer scope. Now this so outer scope in this case means global scope, So what's happening here is that PyCharm is telling us that we've got a variable called robot that is in our global scope, and we've got a variable called robot that is in our local scope. And what's actually happening is that this is a local version of the robot of a variable, and this is a global variable. So now that we have an idea of what's going on, what about if I change this to be robot1, and then I'm going to get rid of those two, and then I'm going to try print robot1. Now, as you can see, we've got a red line, red squiggly line thing, and it says unresolved reference to robot1. Excuse me. So what this means is that inside our function, we have created a local variable that's printing out, which is fine. And then we are, in fact, what I'll do is I'll run this, because the interesting thing about Python, and possibly what's quite useful about it, is that it interprets rather than compiles. So in an interpreted language, what happens is that the interpreter starts from the top of the program and goes down line by line. So in this case, it will go from here to there, there, then it goes down to change, then the interpreter will go up to here, here, and here, and then it will go back to here. So although we've got an error in our PyCharm code, we're still able to run it to see where it stops, how it stops, and why it stops, which in something like C# or C++, you won't be able to do because that's a compiled language. Or to be pedantic, it's a just-in-time compiled language, C#, where that means that the compiler takes everything, compiles it into some kind of executable file, and runs it, whereas this, it goes down line by line, which can be helpful for debugging, because as we can see, we have indeed found an error on our final line where it said print robot1, and print robot1 is not defined. This means that although robot1 in here does exist, and also if we meant to change the robot1 there, the print statement to say robot1, but if we also run it again, we can see that we are printing out Pepper, which is robot1, so the variable does exist. It does exist because we can change this. Let's say we're going to change it to Entran, because that's an awesome robot. Entran. Print. So we can see that the variable does indeed change, but that's fine. Sorry. Yeah, we can see that the variable does indeed change and print out, but as soon as we try to access that outside of its local scope, we can't, because it's already been removed from memory. So that's a basic introduction to scope, and hopefully you've got that. If you haven't, let me know in the comments or the labs or workshops or whatever, and I'm more than happy to help you out with any of that. Because scope's quite an interesting topic. So what we're going to do now is get rid of all of that and start again, because there's something afoot. There's something quite interesting about all of this, and that is what happens if we get rid of our string variable and instead we have some lists. Bloody hell. Sorry, let me just decline that call. Sorry if any of that came up in the video. I've lost my train of thought. La-di-da-di-da. Anyway, yes, I know what I'm doing. That needs an equal sign. So, robot is equal to, let's say it's equal. Where's just give me a second. Okay, let's try this again. Robot is equal to, let's say it's equal to vector pepper and it's equal to mtran. And let's create a new function called change, and we're going to say that robot, let's say robot, which one should we change? The first one. Robot 0 is equal to, and let's say it's going to be Atlas. Cool. And then what we're going to do is we're going to output all of these values. So to do that, as always, we're going to need a for loop. So for, let's say, actually what I'm going to do is change that to robots because it's going to make me feel happy. Robots, and for robot in robots, print robot, and cool. Then what we're going to do is we're going to print this out again, like so. Now, put that there. Now, have a think. Again, pause the video if you want, and have a think what you what the output of this is going to be. We've got a for loop, so it's going to output these three values, and I need to put change in there as well. So change. Cool. Yeah, so have a think what you think the output is going to be. We're obviously going to have 9 outputs. We're going to have vector pepper mtran. We're then going to possibly have Atlas, pepper and mtran in this case because we're changing it. But then what do you think the output for this bit is going to be? Do you think it's going to imitate what we had for the string, excuse me, the string section? Or do you think it's going to keep the this Atlas inside element 0? So let's run it. Okie doke. So we've got vector pepper mtran, which was what we expected for the first one. We've then got Atlas pepper mtran, which is what we expected for the second one. But this is where it gets interesting because it's changed to Atlas pepper mtran. Now that means that what's happened is that we've actually changed an element inside our global list. Now what's going on here? Because before, when we just had the string variable, when we just had a string, it wouldn't change. In fact, what would happen is, as you saw, we would have vector pepper vector. It would go back to its global variable because the local one was destroyed, right? It was removed from the memory. So in this case, what's happened is that actually we've kept it. We've kept this new value and now we're outputting it. So what's going on? Is it one rule for one and all that lot? Well, there is a really good reason for this. And if I just get up, so if I bring this, oh my blimey, there we go. If I bring this across, we can see mutable and immutable objects. So this means that, what this is saying is that there are certain objects that can or cannot be changed. So the mutable objects are things like list, dict, which is a dictionary, and we've got byte arrays and sets. Then what we've got are immutable objects, which are things like integers, floats, complex numbers, and the big one, which we were dealing with, which is a string. So what's going on is that in our new example, we're using lists. And list, as you can see, is a mutable object. That means that we can change it irrespective of where it is in our code. We can change it. So, and with the previous example, with the string, we were using an immutable object, meaning that as soon as we tried to change it, it created its own new local object. So this is a really important concept to get your head around, the difference between mutable and immutable objects, and where mutable objects you can change the value. As we can see here, it's changed it and it's kept the new value, whereas in the string one, although we changed it, we didn't necessarily change the global version of it. Excuse me, we created our own local copy, or rather we created our own local version of the string. So that's a really, really important concept to get your head around, because it can mess you up quite significantly in the future. So the final thing that I want to leave you with is two things, well, really. And the first one is, what happens if I tell you that if we go back to the string stuff, which might take, oh, there we go, good stuff. And let's just change that to robot. Let's change that. Let's put that back to robot. And let's run this. So we've got vector, pepper, vector, good stuff. Okay, well, I can't remember the quote now, but anyway, what if I told you, there we go, what if I told you that we can change the robot to being pepper, and we can have that reflected in our global scope, i.e. we can, in fact, change it so that it doesn't output vector, pepper, vector. Instead, it outputs vector, pepper, pepper. Now, this is interesting because there's two ways of doing this. The first one I'm not a fan of, which I'll get to in just a second. The other way we've already seen in the previous video if you were watching, I think. Anyway, the first one is we need to use a keyword, Python keyword, which is global. Global, there we go. And we need to say robot. That's all we need to do. We just need to write two things, global and a variable name. And if we now print this or run it, we can see that it's changed to pepper. We can see vector, pepper, pepper. So what we've done inside here is we've changed a variable and it's reflected in our global scope. And if we print out the ID of robot now, robot, and we run it, we can see that the first one, our first, where we declared robot first, we've got a value of 512 at the end. Then we've got our new one, where we assign here, which is a value of 600. And when we get out of here, when we get out of this local scope, originally it would be destroyed and removed, and we would be calling this one. Instead, because we've added global, we've said we've actually got 600. So what's going on here is that actually we're creating a globally accessible variable and changing what's happening up here. So this is really cool because what's happening is originally we couldn't do this. We couldn't change a string value because it's immutable, which I guess is still the same thing. It is immutable, but we're creating a new string, and that new string, although it was created in local scope, we've said actually we want this in global scope, which means now that that has been essentially returned, and now we are actually using the one that we have that we made inside here. So that's interesting. That's quite cool. There is something to be wary of then, because this can be really, really, I was going to say beneficial. It can be, but it can also be, it can have hidden consequences. And what I mean by that is that it can be difficult because inside, as I said before, a local variable, creating a local variable inside a function, that's, a local variable is inside a function. But now we've got this global variable inside a function, so we're dealing with global variables and local variables in the same function, which can get really, really messy, and potentially you could make an error in your code somewhere, which could affect lots of bad things and make the universe implode, which hopefully it won't, but you never know. So what can we do about this? Well, we can look at what we did for the previous video, and with that what we did was we used the return function, the return keyword, the return Python keyword. So what we can do is we can say, in this case, robot1 is equal to Pepper, and we can print it out fine, we can print the ID, but then what we can do is return robot1, assign the output or assign the returning output of change back in to robot1. So we can say that robot is equal to change. And what will happen now, hopefully, is we've got the same value. And in fact, we can see that actually we've got the same ID as well. We've got 696, 696. So although I would argue that this is a better way of doing it, because we're explicitly saying, I'll just reformat, we're explicitly saying that the output of change is going into robot. And I would argue that that's a better way of doing it rather than just saying global, because you're dealing with global variables, local variables, all inside a single function, and that's not necessarily a great thing. What we want is for the output of a function to change the global part of it, the global variable, to, rather than everything being inside one function. It's going to look horrible, it's going to be messy, and you're going to get into spaghetti code, which is the technical term computer scientists use for code that's kind of everywhere and loops all over the place and stuff like that. It's horrible, it's nasty, and it's really difficult to debug. Whereas with this, with simply looking at it, we can say, okay, we've got an output of robot1, we're returning that output, the returned output is going into robot, and this is absolutely fine. So that's how I would recommend doing this. So I realise this video is getting a bit long, but it's an important concept to get your head around, and it's undoubtedly going to mess up your code somewhere. So it's really important that you get this, and that you get the difference between immutable objects, mutable objects, and globally and local scope. So is there anything I will add to this? I guess one more thing that could be quite interesting is you're more than welcome to do this if you want, or if not, you don't need to. But we can put things like let's say we can put in robot name. So, and here we can say, let's just put in a string, and let's say open dog. And what's going on here is we can say that, why not? Let's say robot1 is equal to robot name. And now it's going to print out robot1, print out the ID of robot1, return it, and we should find that it prints out OpenDog as well. So this is just an additional thing. We're just showing that we can also pass in values like this, and they go up to here. We give it a new variable. You don't need to do this. In fact, what you can do really simply is just say return robot name, and it will print robot name and then print ID of robot name, and run. we can see the output's again the same thing. And yeah, so this just passing of arguments, it's just an extra additional thing that you can do, which is quite cool. But what I would really say is instead of using global and robot and then robot is equal to robot name, I'm getting rid of that. That's not on. That's interesting. What have I done? What have I done that is wrong? Oh, you spanner. There we go. So, just quickly, the thing that I did wrong here was because I have put in an equal sign, assignment operator, which is what it's called, and a variable. It's expecting that it's expecting that it doesn't. It's expecting a return. It's expecting that we return something, and I wasn't returning something in this case because I'm using global. So if I could just get rid of that, and then we write print, and we do print robot, print the ID of robot, play. We can see that yes, again it's the same value, and this time we're using global rather than returning and assigning. But I would argue that this is probably a bad way of doing it, and that instead you should ideally return and assign to the global variable. So that's it for this video. I think the next video we might be looking at, in fact, the next video I might look at some very simple ways of winning the game, so winning conditions. Because obviously in noughts and crosses you've got a vertical winning condition, you've got a diagonal winning condition, and you've also, I guess in theory, you've got the other a secondary diagonal you can go. So you've got obviously the vertical, horizontal, and two diagonal positions you can go to. So that's what I might look at in the next video, and then in the workshop that's coming up, we're going to put all of this together and we're going to build our noughts and crosses game so it fully works, and that should be really cool. So yeah, I hope that will make sense. Again, if not, post down in the comments, post on Discord or whatever. And again, if you're having a bit of trouble, more than welcome to message me if you're a Robot Society member. And additionally, the workshop's coming up, so you're more than welcome to ask any questions in that as well. But hope this was okay, and have a good day.